The ocean's smartest hunters do not always chase their prey. Sometimes they build traps, create walls, fake signals, or wait motionless until escape becomes almost impossible. A humpback whale can turn bubbles into a fishing net. Dolphins can herd thousands of fish like underwater shepherds. Some spiders lure prey with deception instead of speed. Crocodilians can transform stillness into a weapon. And orcas may coordinate attacks so precisely that each animal seems to understand its role. None of these hunters has a military commander giving orders. Yet their strategies can look carefully planned. So how do animals turn water, chemistry, patience, and teamwork into hunting technology? Start with one of the strangest nets on Earth. It has no rope, no hooks, no human hands. It is made entirely from air. In some populations, humpback whales use a technique called bubble net feeding. The target is often schooling fish or krill. One or more whales dive beneath the prey. Then bubbles begin rising through the water. At first, that sounds almost useless. Fish can swim through bubbles. But a dense curtain of bubbles can disturb and concentrate a school. The whales may circle underneath while releasing air from their blowholes. The rising bubbles form something like a cylindrical barrier. The prey packs tighter together. That is exactly what the whales need. Then the attack changes direction. Instead of chasing individual fish sideways, whales accelerate upward through the concentrated school. Their enormous mouths open wide. Water, fish, and everything nearby rush inside. The whales close their mouths and force water through baleen plates. The water escapes. The food stays. A cloud of bubbles has just become hunting equipment. Even more impressive, some humpbacks cooperate during these hunts. Individuals may perform different movements during the feeding sequence. Researchers have documented variation between groups, which means bubble net feeding is not one identical behavior everywhere. This is not a rigid underwater recipe. It is a flexible hunting tradition. Now move away from whales and watch dolphins approach the same basic problem. One fish is difficult to catch. A tightly packed ball of fish is much easier. Many dolphins hunt schooling fish cooperatively. They can surround, compress, or drive prey toward locations where escape becomes harder. Some dolphins take turns moving through a concentrated school, while others help maintain its shape. Imagine trying to catch confetti floating in a swimming pool. Grabbing one piece at a time would be miserable. Push all the confetti into one corner, and suddenly the problem changes. That is the logic of herding. Different dolphin populations also develop specialized local techniques. Some drive fish toward shore. Some use mud to create barriers. Others coordinate movements in open water. The important point is not that every dolphin hunts identically. It is that intelligent predators can manipulate the movement of prey instead of simply outrunning it. And then nature gets even stranger. Because some hunters do not build barriers at all. They manipulate information. Consider bolas spiders. Instead of constructing the classic large web many people expect, female bolas spiders can produce chemical signals that imitate components of female moth sex pheromones. Male moths detect what appears to be a promising signal. They fly toward it. That decision is extremely reasonable from the moth's perspective. Unfortunately, the female moth is a spider holding a sticky weapon. The spider swings a silk line, ending in a sticky droplet. If the moth comes close enough, the bolas can strike and adhere to it. No sprinting, no giant web, just biological deception. It is almost like phishing email invented by evolution, except clicking the suspicious link has much worse consequences. Other spiders use different forms of deception or specialized lures, but the deeper principle is the same. Predators do not always attack muscles. Sometimes they attack the prey's decision-making system. Now compare that delicate chemical trick with an animal built like a living armored vehicle. A crocodilian may spend astonishing amounts of time doing almost nothing. That inactivity is not laziness. It is part of the strategy. Crocodiles and alligators are ambush predators. Their eyes and nostrils sit high on the head, allowing much of the body to remain submerged while they monitor the surface. The hunter minimizes movement. The prey sees very little. Then distance becomes the critical variable. A crocodilian does not need to be faster than every animal across a long chase. It needs explosive acceleration across the final short distance. That changes everything. Patience replaces pursuit. Camouflage replaces constant movement. Timing becomes more important than endurance. When prey approaches the water's edge, the predator can launch rapidly, seize it with powerful jaws, and attempt to drag it into a position where escape becomes difficult. The trap existed before the attack began. It was the predator's stillness. But there is another hunting system where the trap is not created by one individual. It is created by a team. Orcas, also called killer whales, hunt an extraordinary variety of prey. Different populations specialize in different foods, and their techniques can differ dramatically. That matters because there is no single universal orca hunting strategy. Some hunt fish. Some pursue marine mammals. Some target rays, sharks, or other prey. And some hunting traditions depend heavily on cooperation. When attacking schooling fish, orcas may coordinate their positions to concentrate prey. Certain fish-eating populations have been observed using tail strikes to stun fish after grouping them. Elsewhere, orcas hunting seals near ice may work together to create waves that wash prey from floating ice. Think about what that requires. The seal is not simply being chased. Its platform is being manipulated. Several whales may swim in coordinated formation. Their movement generates a wave. The wave reaches the ice. The seal loses the advantage of staying above water. The environment itself becomes part of the attack. Other groups use different tactics because they hunt different prey under different conditions. That is the key. Orcas are not impressive because every group knows every technique. They are impressive because specialized hunting behaviors can be learned and maintained within social groups. A young orca does not enter a simple world where instinct alone solves every problem. It grows inside a hunting culture. Now place all 5 strategies beside each other. Humpbacks manipulate space with bubbles. Dolphins manipulate prey movement through herding. Bolas spiders manipulate sensory information. Crocodilians manipulate timing through concealment and patience. Orcas can manipulate prey, teammates, and even physical features of the environment. The weapons look completely different, but the logic underneath them is surprisingly similar. Efficient predators rarely waste energy solving the hardest version of a problem. They change the problem first. Instead of chasing scattered fish, concentrate them. Instead of searching for moths, make moths approach you. Instead of pursuing prey for minutes, wait until it is within meters. Instead of attacking a seal on safe ice, make the ice less safe. Evolution does not reward dramatic effort. It rewards strategies that work well enough to survive and reproduce. And that may be the most fascinating part of animal hunting. The teeth, claws, and muscles are obvious. The invisible weapons are harder to notice. Information, position, timing, cooperation, tradition. The most dangerous moment for prey may not be when the predator finally attacks. It may be several seconds earlier, when the predator quietly changes the situation, so that almost every remaining choice becomes worse.